Hello everyone, this is Ketisha. In this video, I'm going to go through the 2023 Combined Science Physics Paper 2 Foundation Tier. Question number 2 is on the topic of forces, mainly to do with stopping distance. A car contains a device called a black box. The black box records the distance traveled and the time taken for each journey. Figure 3 shows the distance time graph for each part of a journey. So as you can see in the graph, you got on the x-axis the distance in meters, and the y-axis is the time in seconds, is going up to about 9 seconds, and the line is actually going straight up, and they are showing the point at which the brakes are applied, which is about 4 seconds here. So let's have a look at question 2.1. Which feature of figure 3 shows that the car travels at a constant speed for the first 4 seconds? In the first 4 seconds, before the brakes are applied here, what part of the graph shows that it's actually traveling at a constant speed? Well, as you can see, that is actually a straight line, but it's not a flat line. So the line becomes horizontal. Well, in the first 4 seconds, it's not becoming horizontal. Horizontal means it's actually a flat line, right? The line goes through the origin. Origin means it's actually going through 0, like here. Now, the line is straight. That is the correct answer. After 4 seconds, the driver applied the brakes and the car stopped or slowed down and stopped. The distance the car traveled after the brakes were applied is called the braking distance. Determine the braking distance of the car. Use figure 3. So let's read that back again. The distance the car traveled after the brakes were applied is called the braking distance. So after the brakes were applied over here, the distance the car traveled between 4 to 9 seconds is called the braking distance. So at what distance were the brakes applied? So if you go across, it's actually 2 boxes up from 60. So what would be that value? That's 64. Let me bring that up again. And the car's distance is actually the same after just past 6 seconds. Right? So what is the distance over here is actually remaining the same. It's actually a flat line. That means it's actually stopped here. So at this point, more or less, it's actually stopped. So at what distance does it stop? That's 84. Each box, as you can see, there's 5 boxes between 0 and 5, 10. So if I divide 10 by 5, that gives me 2. So each box is 2 meters. That's why. So 80, 82 meters, and then 84. So what is the distance traveled? Well, I'll just take away 84 minus 64. So 84 minus 64 gives me 20 meters. Next question. The black box also records the deceleration of the car. Deceleration means it's the slowing down of the car. As the car decelerates, the velocity of the car changes by 16 meters per second. Velocity of the car changes by 16 meters per second. The car decelerates for 2.5 seconds. That is actually the time. Calculate the deceleration of the car. Use the equation. So they have given you the equation. Deceleration equals change in velocity, which is 16, as they have said over here, divided by the time taken, 2.5. So again, let's bring up the calculator. So 16 divided by 2.5 gives me, it gives me 32 over 5. So I'm going to press this button ST, and that gives me 6.4. So it's 6.4 meters per second square. Question 2.4. If the black box records large decelerations, it identifies that the driving may be dangerous. Why can large decelerations be dangerous? Well, if you decelerate really fast, if you try stopping the car really quickly, why will it be dangerous? The brakes in the car can overheat. That is true. If you do it far too often, the brakes can overheat. The driver may lose control of the car. Yes, you could lose control of the car. You're only asked to tick 2 boxes. Let's check if the others are correct as well. The force applied by the brakes is very small. We don't know that. That depends on how much force you are pushing on the pedal, brakes. The reaction time of the driver increases. No. Reaction time is how fast you are reacting. The thinking distance is very short. Right? True, but that doesn't mean it's going to be dangerous. That's actually a good thing. So it's only the first 2 answers. The black box monitors the speed of the car. Describe how speed affects braking distance. Now, if you have a bigger speed, how does the speed affect your braking distance? Right? If you are traveling at a low speed, like 20 miles per hour, then your braking distance is usually smaller. The car will actually come to a stop really in a short distance. But if the brake speed is higher, like 80 miles per hour, then the distance the car travels while you're braking is going to be longer. So we can describe that as speed increases, the braking distance would also increase. That brings us to the end of question number 2, and I will see you in question number 3.